let's go over number 15 of the SOA sample questions for exam P. So this is kind of like a very unique question and how they kind of like word it. So let's go ahead and read it. An insurer offers a health plan to the employees of a large company. As part of this plan, the individual employees may choose exactly two of the supplementary coverages, A, B, and C, or they may choose no supplementary coverages. The proportions of the company's employees that choose coverages A, B, and C are 1 divided by 4, 1 divided by 3, and 5 divided by 12, respectively. Determine the probability that a randomly chosen employee will choose no supplementary coverages. Okay, so this is, again, sort of a Venn diagram problem, but it's not your typical Venn diagram problem. So let's draw a box first to denote 100% of the population. And let's draw circles for A, B, and C. Okay, so let's call this A, B, and C. Now, we know that an employee can only choose so if they were going to choose a coverage, they could only choose exactly two. And if they were not going to choose anything, they would have nothing, right? But let's worry about the exactly two. So that means that this part of the Venn diagram does not matter. This part of the Venn diagram also does not matter. This part of the Venn diagram also does not matter because they can't choose those parts of the Venn diagram. They also cannot choose this part of the Venn diagram. The only things that matter are here, here, and here. So the ones where there's only two circles intersecting at all times. So let's name each of these. So I'm going to call this X. I'm going to call this Y. And I'm going to call this Z. Okay, so now we have X, Y, and Z. Let's think about the probability of having a coverage A. So we know having coverage A, it's going to be 1/4. The probability of having coverage A is going to be 1/4. So probability of having coverage A is equal to 1/4, which is equal to X plus Z. Now, we can also do probability of having coverage B. Right, coverage B is going to be X plus Y, right? But that's also 1/3 is equal to X plus Y. And then probability of C, right up here, so I have room. It's going to be 5/12, and that's going to be Y plus Z plus Z. Okay, so now we have kind of like our equations, and now it's just up to us to sort of solve everything. So let's start with A first. So let's just let's set this equation to find what X is equal to. So X is equal to 1/4 minus Z. Okay. Now let's go with, let's see. Let's do what Z is equal to from probability Z. So C. So Z is equal to 5/12 minus y. And let's plug in these things for probability of b. Let's plug in x first, and then we'll plug in z afterwards. Okay, so 1/3 is equal to x plus y. So that's going to be 1/3 is equal to 1/4 minus z plus y. And then now let's plug in z here. So it's going to be 1/3 is equal to 1/4 minus 5/12 plus y plus another y. Okay. Now let's just solve for y. So that's gonna be 1, 4. So it's gonna be 0.5 is equal to 2y. So y is equal to 0.25. Okay, so now we have y here. So let's calculate what z is going to equal to. So z is going to equal 12 minus 0.25, and that's going to be 0.167. Shade that. And then and then x is going to equal 0.083. Okay, so now we have y, z, and x. Okay, so now we want to figure out what this probability is, because we want to determine the probability that someone will choose no supplementary coverages, but these x, y, and z are the probability that someone has chosen a supplementary coverage. So how do we solve for this area outside of the Venn diagram, but within the box? So all we have to do is just take the complement of x, y, and z. So that's going to be 1 minus 0.083 minus 0.25 minus 0.167. And that's going to be 0.83 minus 0.25 minus 0.167. That's going to be 0.5. Okay, and so because we know that the probability of landing outside of the Venn diagram is 0.5, that means our answer choice is going to be number C. If you liked this explanation or just made it easier for you to understand how to solve this question, please leave a like. If you have any questions or comments, leave a comment, and I'll see you in the next video.